Now, in the last video where I introduced integration by parts, I gave you the integral of x multiplied by e to the x dx, and I said try to see if you can be able to integrate this. Now let me just do it along with you. Now notice that on this case you can be able to find the integral of anything. The integral of x is going to be half x squared, and the integral of e to the x will just stay the same. Now from the formula, the integral of u dv, which is the same as uv minus the integral of v dv du, Now in this case you're trying to find the integral of e of x times e to the x, and we're going to apply this formula. Now in this case, what's your u? Well, you first realize which one will be able to be integrated easily. Well, it's easy to integrate e to the x. It will not give you a fraction like x, since the integral of x is going to be half x squared. So, and then you realize that if you integrate x, you're going to have a problem here, so it won't take you anywhere. So in this case, let u equals x, so dv will be this one. So on that assumption, we're going to have x, and the integral of e to the x, it's e to the x. Then you can subtract the integral of e to the x. In this case, du would be dx, since the derivative of x will just be dx, so you don't have any extra term in this one. So we're going to have something like this. So if you further simplify this, you're going to have x multiplied by e to the x, and the integral of e to the x is e to the x. Don't forget to add that constant when you're done. I hope you have something like this as the final thing. That's the integral of this. You can basically do it with integration by parts. Substitution won't work. It's not a composition, this one. Then the answer to this case will be this one, and I hope you got it. So how do you confirm that this is correct? We can just find the derivative of this. The derivative of a constant is 0, and the derivative of this will remain the same, and then you can use the product rule on this one. The final answer you get is gonna be this one. So that's how you can work through substitution. So let's try to find the integral of another thing. To make matters interesting, let's say x squared, the natural log of x dx. Let's say we're trying to find the integral of this. In the last one I did x, the natural log of x, but this one seems more interesting because the square there. So what's your u and what's your dv? So integrating ln x will be a problem, so I'm just going to rearrange this to be ln x multiplied by x squared dx. So this one is my u, and my dv will be this one. Now if I apply integration by parts, I'm just going to use this formula there. So I'll have u, which is ln x, and then I multiply by the integral. The formula is this one. I multiply by the integral of x squared. So the integral of x squared is going to be 1 over 3 x to the third. So we're going to have 3 in the denominator, and we'll have x to the third here, and then you subtract the integral of that 1 over 3 x to the third, or x to the third over 3. That's the integral of x squared. Then the derivative of the natural log of x, it's going to be 1 over x, then dx of that. So you're going to have something like this. Then you're going to have x to the third, the natural log of x, divided by 3, minus, you can take the 1 over 3 outside. We know this because the properties of integration, or the rules that I showed you when I was introducing integrals. You can take the constant outside. Then you'll have x to the third divided by x, which is just x squared. Now the integral of x squared, remember I have x to the third and the natural log of x. Then you divide by 3 minus 1 over 3. The integral of x squared is x to the third over 3. Then don't forget to add that constant when you're done integrating everything. So this will further simplify to x to the third, the natural log of x, divided by 3 minus 1 over 9, or x to the third over 9. So that's how this can be done. That's how you can like solve this using integration by parts. So it's basically this simple really. Okay, now I'm just going to end this video with a very, very complicated problem, just to like show you it's not really that hard as long as you like know what you're doing. I'm gonna do a complicated problem here. Now there's a reason why most people hate trigonometry. So now let's focus on this integral. You have x and you have sine. Note that the square is inside the sine, so it's sine of x squared. So the x squared is just one thing itself. And then they ask you to like find the integral of this. Now what's your u and what's your dv? Notice that integrating sine of x squared is gonna give us a bit of a problem. But then I know we can like integrate it, but then I'm trying to like avoid this one. But then you can do it because you know the integral of sine is cos. So we're gonna do by parts, right? Okay, let's look at this. Will it be safe to say that this is a composition? Let's look at it. Do you see any composition? Suppose I were to say that u equals x squared. Then I realize that du will be 2x dx, and then if you solve for dx, you'll get dx equals du over 2x, and notice that this x will cancel with this one. So basically, you can basically see that this is a composition, so you don't do by parts here. So here I was just like trying to like show you that you have to be able to like distinguish between the two, integration by parts and integration through substitution. Because I know that most people here we're gonna do integration by parts, but you can basically see that substitution works. You can do substitution on this one. Don't do by parts. Although if you try to like work it correctly, you'll still get the same answer. But then it's not really necessary because you can see you have a composition of the functions here. Okay. So I hope like right now you can be able to like distinguish between u substitution and integration by parts. This one is a substitution question. You must be able to like differentiate between the two. If you don't, then you'll end up doing by parts where it's not really necessary, and you'll end up doing substitution where it's not really necessary. Okay, let's proceed. Okay, what I wanted to do this. I wanted to do 1 over x, the natural log of x, of 1 over x, dx. Try to like see if you can like find the integral of this. Can you find the integral of this? Test yourself. Just pause the video and see if you can like be able to like integrate this. Okay, so yeah, first thing is first. Which technique of integration are you going to use? Substitution or by parts? Okay, let's look at this. Do you see any composition? Well, I do. Okay, so let u equals the natural log of 1 over x. Let u, this is u, equals the natural log of 1 over x. Then du in this case is going to be what? The derivative of this. This is interesting. The derivative of the natural log of 1 over x is going to be what? Basically, you divide by the inside and then you derivate the inside. The derivative of 1 over x, it's minus 1 over x squared. Then notice that if you multiply both sides by by x squared. If you multiply both the numerator and the denominator by x squared, notice that this will cancel this, and here you'll have x. So the x squared and this one will cancel, then you'll be left with minus 1, and x squared multiplied by 1 over x is going to be x, and then you have something like this. Du is going to be minus 1 over x dx, and then if you solve for dx in this case, you realize that dx will be minus x du if you solve for dx in this case. So you're basically going to have something like this. Then you plug that in, then you have the integral of 1 over x, where the natural log of 1 over x is u. Then you have u, and dx is the same as negative x du. Then notice that this x will cancel this x, and then you'll have the integral of minus u. I'm just going to take the negatives outside. Then I have minus u du. What is the integral of u? The integral of u is going to be u squared divided by 2, or half u squared. Then don't forget to add that constant when you're done. But now what's u? U is equals to the natural log of 1 over x. Then you substitute that back in, the natural log of 1 over x, and it's that square, and then you divide by 2, and you add your constant, and now you can further simplify this. The natural log of 1 over x is the same as minus the natural log of x. Notice that you have a square there, which is going to cancel that negative, and then you'll have the natural log of x squared divided by 2, negative that, and you add your constant there. So you see that the substitution and integration by parts, you have to be able to distinguish them. Where do you do by parts and where do you do substitution? And here I'm just mixing problems, so you can be able to maybe catch something from this, realize where you apply by parts and where you apply substitution, because this can be tricky, because some people might have done by parts here, and then it was gonna be a problem, because you can literally do this with substitution, and it works because